today, the first lesson of that unit. We're still in functions, okay? We just decided to split up the functions unit so that way, it's not just one huge test on like everything function related. This particular unit is going to be more of the algebraic processes dealing with functions, such as function operations, composite of functions, inverse of functions, transformations of functions, etc., etc. So we're starting it out. You guys are going to be learning how to perform operations given two different functions, okay? Who knows, maybe even three if we get a little fancy, okay? So when you open up your first flap, we're talking about adding and subtracting functions. Literally, when you are adding and subtracting functions, you literally are putting the two functions together, okay? Combining like terms of the two functions, which can be written in either way. As you see, you have f plus g of x, or f of x plus g of x. Do not be confused. This right here does not mean multiplication. It literally means I'm taking the f function, I'm adding it to the g function. I'm taking the f function and I'm subtracting the g function, okay? So after you add them together, you might have to combine like terms at the end, and then that's it, adding and subtracting, okay? So we have two functions, f of x equals 7x minus 2, g of x equals square root of x plus 2x. What are f plus g of x and f minus g of x? Again, this is not multiplication, this is addition and subtraction. So we're literally going to add f and g together. So that's 7x minus 2 plus square root of x plus 2x. Okay? Once I have that, can I combine any like terms? What? 7x and 2x. So now I have 9x minus 2 plus the square root of x. I can't combine anything else from here, so that is my answer. That's the sum of f and g. Everybody with me? Now I'm going to subtract. Now subtraction can be a tad bit, not a tad, it can be tricky. Because a lot of students forget that you're subtracting the entire g function, which means that when I write it, I'm going to write it using parentheses, because that subtraction applies to the entire g function, which means I'm going to need to do what? With that negative on the outside, that minus. Distribute it through, okay? So then that becomes 7x minus 2 minus square root of x and minus 2x. A lot of times students mess up because they don't distribute the negative over. They'll subtract that first term, but they'll forget about the other terms that come after it. Can I combine like terms? What? 7x minus 2x, and I'm literally putting them together. I'm not adding 2x to 7x, I am subtracting, okay? So 7x minus 2x is 5x minus 2 minus the square root of x, and that is f minus g of x. Am I done? No. What else do I have to do? Find the domains, and this is why we spend that extra time making sure you guys knew how to find domains of functions, okay? Because if I look at the result, the sum and the difference between f and g, what do you see in both of them? You got a square root of x, and you can't take the square root of what numbers? Negative numbers, which means that these domains are not going to be all real numbers. Whenever I have a square root, what do I have to do to the part that's underneath the square root? Equal to 0? Greater than or equal to. So whatever's underneath the square root, which is just x, you have to set that greater than or equal to 0 and solve if necessary. Do I need to solve anything? No. So there's my domain. If I want to write it in set notation, what do I need? Curly brackets. Such that, and at the end? Very good. What about in the red? What about the f minus g? Do I have any restrictions? Is it all real numbers?
No, because you don't still have to put because it's not
Got the square root. So again, whatever's underneath the square root, I have to set it greater than or equal to 0 and solve if necessary, which I don't need to. Just to make sure we get the practice, how do I write that in interval notation? X is greater than or equal to 0.
0 with the little bracket.
0 with the bracket.
Comma, the infinity.
And the infinity.
And the bracket.
There you go. So that's both ways. Before anybody says anything, know the domains of like the sum and the difference won't always be the exact same thing. It really depends on what the functions are. Okay? Questions on adding and subtracting? Multiplication and division. Okay? Closed dot. Two functions being attached to each other. You can even add in fg of x. This is another way to represent multiplication. Okay? fg of x, that's f of x times g of x. And then, of course, the division. Okay? Remember, anytime we have a denominator, we kind of have to be cautious of, making sure that those values can equal 0 in the denominator. God heaven forbid there's a radical in there as well. Okay? So, we have two functions, 2x squared minus 9x minus 5, and g of x, 5, which is 5x, x minus 5, Jesus. What is f times g of x? That means we're going to literally multiply these two functions together. Trinomial and binomial together. To multiply, I'm going to have to do some distribution. What's 2x squared times x?
2x cubed.
So it's a third. What is, and I'm gonna go this way because I'd rather work with like the smaller. What's x times negative 9x?
Negative 9x squared.
What's x times negative 5?
Negative 5x.
Now I need to do the negative 5 to all of them. What's negative 5 times 2x squared?
Negative 10x squared.
Negative 10x squared. What's negative 5 times negative 9x? 45x. And what's negative 5 times negative 5?
Positive 25.
Positive 25. Watch your signs when you're multiplying. Okay? Watch your signs when you're multiplying. Now, can I combine any like terms?
Yes.
Very much so. I like doing it this way because then I can see the terms I need to add. What's negative 9x squared minus 10x squared? Negative 19x squared. Negative 5x plus 45x.
44 40x.
And then 25 just stays as it is. So a little bit of algebra to work this one out. Any restrictions? So my domain is all real numbers. And I'm going to write in an interval notation this time. Doesn't matter, either one. Unless I specify which way, like in the test, I wanted to see both ways. At this point, whichever one you feel more comfortable with. Now we need to divide. Which one goes on top? So it's going to be 2x squared minus 9x minus 5 all over x minus 5. Okay? Now, before we just stop and be like, all right, we're done, let's go ahead and find the domain, we have to check to make sure that we can't simplify this anymore. Okay? How am I going to know if it simplifies? I need to factor the top and bottom if necessary. Okay? We talked about factoring before. When there's a number in front, you got to multiply to the c. What's 5 times negative 2 times negative 5? I almost said the whole answer. Negative 10. Then down here goes negative 9. Are there two numbers that multiply to give you negative 10? Add together to give you negative 9. 10 and 1. Which one's the negative? The 10. Okay. So then, give me 1 second. I need a little bit more space. Okay, so that gives me x minus 10 times x plus 1. What do I need to do? Divide by 2. It looks like it does factor. What's 10 over 2?
5.
So x minus 5. And this one becomes what? 2x plus 1. Remember, that slide divide bottoms up. You multiply the 2 and the negative 5. Make your x. Find your factors. Divide. And bottoms up. Can I simplify it now?
Yes.
What happens? Those cancel out. So my final answer is 2x plus 1. That's f divided by g.
So do we always have to put the stuff in the front?
Like in your homework, I'm going to ask you to do like 2 things for like the same 2 functions. So for me, when it comes to like grading which is which, if you could just kind of, help me out so I know which one's the addition, which one's the multiplication. But a lot of times it'll just be like one function. I'm going to test it because one function, one function. Now, we still have to do our domain. Make a note somewhere. Make a note somewhere. With division, you always base it off of the original division before you simplify. Okay? So, for division, you always do the domain before you simplify. Like you use that non-simplified answer to find the domain. Okay? Because even though it's simplified to be something that was, nice and neat, we originally had 2 functions that were being divided, and there was indeed a denominator. When there's a denominator, we have to do what with the denominator?
Equal to 0.
So if x minus 5 equals 0, x is equal to what? Which means that my domain is everything but positive 5. So this is my domain for the division, which you see in the orange. So a tad bit tricky, but did everybody make that note? You always do the division, the domain of the division before you simplify, but you want to make sure you simplify your function. Okay? Composition of functions. The composition of function g with function f is written either 2 ways. Okay? It's written with the open circle, not to be confused with the closed circle. What does the closed circle mean? This is not an accident. It is meant to be an open circle. This means composition. Or it can be written, what you see over here on the right. Now you can do this one of 2 ways. You can either evaluate f of x first and then use f of x as an input of g of x. It kind of depends on what it's asking you to do, and so I'll explain that a little bit later. Please note, there's a big difference from f of g of x than g of f of x. And they don't always equal each other, okay? These are saying 2 different things. The first one is saying take the g function and plug that in to the f function. Whereas this one is saying take the f function and plug it into the g function, okay? The domain when you're doing composite functions are basically going to include restrictions of both functions. Because basically they're composed with one another. And you'll see when we look at some examples. Okay? So we have 2 expressions, f and g, and we're going to find each value or expression. Now, this means composite, not multiplication. Personally, I don't like looking at it this way. I like looking at it with the combined way. Okay? That's the other way to write it. Because to me, I can see it a lot easier and say, okay, I need to figure out, order of operations. You work with parentheses. So I have another set of parentheses, and f of 3 is inside that parenthesis, which means I need to figure out what is f of 3. You guys know how to do this. You did this in the last unit. You haven't forgotten how to do this, right? What does f of 3 mean? What do you need to do? Just the f of 3. Don't look at you. 3 into x into which function? F. So that's what I'm going to do. I'm going to take the f function. I'm going to plug 3 into x. What's 3 plus 7? 10. So now f of 3 has been replaced with the 10. Everybody see that? Now what is it saying to do? I need to plug 10 in for x into which function? G. So here's G. I'm going to plug 10 in. That's 10 squared. Minus 1 was 10 squared. Minus 1. So my answer to this, G of f of 3, is equal to 99. You start with the inside, work your way out. The ones with the numbers are very easy to work with, okay? Because, you end up with a number in the end. No need for domain and range when you're given a number, okay? And also doesn't ask for domain and range either, but we're going to do it for the last one. Let's look at this one. I'm going to rewrite it so I can see it a little bit easier. That negative 5. What am I going to do with it? Plug it into G. So I'm going to take care of the inside first. So when I plug negative 5 into x, into the G function, that's negative 5 squared minus 1. What's negative 5 squared? 25. Minus 1? 24. So that 24 is what G of negative 5 is. Which means that 24 needs to go in the f function for every x that I see. That's 24 plus 7. What's 24 plus 7? 31. 31. So my final answer is 31. Remember, start on the inside, work your way out. Questions with the numbers? Now this last one, there's no number here. It's a letter. But you don't treat it any differently. That literally means now, instead of plugging in negative 5 or 3, I'm going to plug in what? A. Into every x that I see in which function? The f function. So working with the inside, when I plug A into the x, I get A plus 7. So now I'm going to take that A plus 7 and do what with it? Plug it into the x's in the G function. So that's A plus 7 squared minus 1. And you're going to have to FOIL. Remember, our binomial squared, you got to FOIL. A times A squared. When I do A times 7 and 7 times A, that's a 7A plus a 7A. 14. 7 times 7. And I need to bring down that minus 1 at the end. So my final answer is A squared plus 14A plus 40. Oh, you're right, it is 48. Sorry, I jumped the gun. And, ooh, I'm telling you, in my mind, I see the answer already. Sorry, this one should have been a 49 minus 1. And I jumped the gun. Sorry, it should have been 48 here for our final answer. All right, combine my like terms. Combine my like. All right? Okay. Now, real quick. When you're doing domain of composite functions, you need to look at every piece. You need to look at the two functions that you plug into one another, and you also got to look at your final result. Are there any restrictions on F? Any restrictions on G? Any restrictions on the composite? So your domain for this would be what? All real numbers, okay? Now, and it's A. Okay, because now we have an A involved. Now, if there was a restriction on any part, you would include that a part of the domain. Okay, so if there was a denominator, if there was a radical, it wouldn't be all real numbers. But wherever there's restriction on any part, the original functions or the composite, then you need to achieve that.
How does that work when it's two variables? Like if X had a restriction and if A had a restriction,
Then
they're not the same variable.
Then you would have the two. You would have X and A. So you would have it in two pieces. So your X and then X is the element of all numbers. So the thing is, remember, we replaced those with that. All right? Questions? What if, because you got some space, right? And this was not what I was talking about for those extra notes. But you got some space. What if I'm using the same two functions as x plus 7 and x squared minus 1? What if it gave you this? What does that mean?
You plug X into G.
You plug x into G, which it already has x.
And then you plug G of X into F.
You will plug the entire function into x of the f function. So that literally means whatever G is, you're plugging that whole thing into f. So then you'll have x squared minus 1, there's the x part, plus 7. Now really these parentheses are just there for that visual. I plug that in for x. But since I'm just adding a 7, that's going to go away. So my final answer is going to be x squared plus 6. Questions? Okay, so be careful, all right? I want to make sure I showed you one where there was nothing there. It was literally just that, okay? You try. All right, so decomposing a function, okay? Now we're going to take the idea of what we were doing as like putting a function into another function and going the opposite direction, because it's a skill that's widely used in calculus, okay? It's basically the idea of looking for an inner function and an outer function. So in other words, what you see down here in these examples is that these are the composite. This is the final answer. So what they basically did was there were two functions, an f function and g function, where they took g and plugged it into f. And your job is to try to figure out what are those two functions, okay? It mentions that neither one of them can be the identity function x. So in other words, one can't be x and the other one be the final answer. Can't do that. So let's see if we can break this apart. When you look at this, this is basically saying, okay, I took one function and plugged it into the other function. There's an inner function and an outer function. Just out of curiosity, does anybody potentially see what those two could be?
F and G.
Right, like what they are. Like, can anybody see what kind of function could G have been that when I took it and plugged it in for F, I got what you see? Think about two separate functions. I even take guesses. It had to compose to be the square root of x to the third minus 4.
It was something with x.
Okay, then what did I plug it into to get the square root of x to the third minus 4?
Into x squared.
What did I plug in? I think I need two separate functions. Two separate functions. You need two functions, and when you put one function to the other, you get the square root of x minus 3, x to the third minus 4.
And it can't be x.
And it cannot be x.
But so
Could it be the square root of x? Yes, it could. Now the question is, would square root of x be the outside function, or would it be the inside function?
the outside.
The outside function. So the outside function, which has to be f, because look at the notation, would be the square root of x. Now, if that's my outside function, what would I plug in for x to get my final answer? It's actually a cube, but okay. So let's just make sure we got this. G of x basically means that I'm going to plug in the g function into f. F is the square root of x. So I'm going to plug in x to the third minus 4 to get the square root of x to the third minus 4. Like, I think y'all might have been overthinking it. I really do think y'all might have been overthinking it. Before we do B, let's do another one. Okay? I'm just going to make these up, all right? Think, what's the inside function? What's the outside function? You said the what function? So outside is f, because the notation, okay? X to the 4, x minus 2. Think about it. If I take x minus 2 and plug it in for x, doesn't the parentheses come? You raise to the 4th power? Let's do another one, okay? Let's do another one. What if I give you, what do those bars mean?
Absolute value.
What's my inside function? What's my outside function? Does everybody see it? Like, are you seeing what encloses everything? Like a parenthesis, an absolute value, a square root. Those all enclose these things. Make some inside functions, right? What's the inside function? So then the outside function,
The absolute value.
and yes, it can really be that simple. Let's do another one before we get to B. Okay, I want to make sure you got this. I want to make sure you got this. Okay? What about, yeah, this one's going to be interesting. Let's see who remembers from,
So then the inside function is the 3x minus 1, and the outside is the 1 over x.
y'all see that? Inside is 3x minus 4. The outside is 1 over x. In the lesson 1-3, I reintroduced you to this function, the reciprocal function. If I take g and plug it into f, don't I get 1 over the whole expression? Okay. Let's look at B. Can you follow me here? Inside out function, outside function. I'm telling you, your outside function is going to be like one of those, like a square root, something being raised to a power, an absolute value. It's going to look like, hey, you put something right here, okay? Now, if you look at B, it doesn't look like any of the other ones. It looks like a regular old function. But what type of function, oh, Jesus, what type of function is it? A good old quadratic. And whenever you hear me say a good old quadratic, it's usually when we have to do what to a quadratic? Factor it. The first thing you look for when you factor is a GCF. Is there a GCF here? What? 2. And if I take out a 2, what am I left with? can already hear some of y'all talking about some, oh, I know what the inside function is, the outside function. I know you probably like, oh yeah, I see what the inside is and what the outside is, but I want y'all to go up a step from like algebra 2 to pre-cal a little bit, okay? Can I factor this part? Yes. Okay, so real quick for those who still need the x, 25 and 10, with two numbers multiplied to give me 25, add together give me 10? 5. So this turns into x plus 5 times x plus 5, which is what? How can I rewrite x plus 5 times x? And now that it's fully factored, can you see the inside function and outside function now? What's my inside function? X plus 5. What's my outside? 2x squared. Beautiful. Because you have the 2 there, I had to replace that x with an x plus 5 and then the square. Okay? Now, some of these is not just one cut and dry answer. Some of y'all may see it a little bit differently, but as long as I take your inside function and plug it into your outside and I get the final result, and it's not x, then we're good.